how's it all gonna end? I mean, not just us or our planet, but everything, the whole universe. The physics behind the ultimate fate of reality is some seriously mind-bending stuff. So, yeah, let's dive right in. To really get our heads in the right space for this, let's start with this quote from physicist Lawrence Krauss. It's a little jarring, right? It doesn't really give a damn about us. But honestly, it frames this whole conversation perfectly. We're talking about scales so massive that our entire existence is just a fleeting blip. And it's that cosmic indifference that makes the physics of it all so incredibly fascinating. Okay, so let's jump from that big philosophical idea of an indifferent universe to a very real, very weird physical theory. One that suggests the universe could just end at any moment without any warning at all. It's a concept called vacuum decay, or maybe a little more dramatically, the false vacuum threat. To get our heads around this, we got to talk about the universe's energy state. The idea is that our universe isn't actually in its most stable state, the lowest possible energy level. Instead, it might be in what's called a metastable or false vacuum. The best way to picture it is to think of a ball sitting in a small dip on the side of a much, much bigger hill. Sure, it's stable for now, but it's not at the real bottom. So here's what that analogy looks like in the language of physics. This graph shows the potential energy of the universe. See that little dip way over on the left? That's us. That's our entire universe, just hanging out in its false vacuum. And now look at that super deep valley way over on the right. That's the true vacuum, a much lower, much more stable energy state that, well, we could potentially fall into. Just take a look at the scale of that drop. It's huge. So what would happen if our little ball got a nudge? Well, thanks to a seriously weird quantum process called tunneling, where a particle can literally pass through a barrier it shouldn't be able to, the universe could suddenly drop into that true vacuum state. And it wouldn't happen everywhere at once. It would start in just one spot, creating a bubble of this new reality. A bubble that would then expand at the speed of light, completely rewriting the laws of physics and, obliterating everything it touched. It is a terrifying thought, right? A silent, instantaneous end that could have already started billions of light years away and be heading right for us. So, if this is a real possibility, why are we still here? What's keeping our universe in its comfy little dip on the hill? Well, the answer comes from one of the absolute strangest ideas in all of quantum mechanics. It turns out the universe might be preventing its own collapse just by observing itself. Yeah, let's unpack that. This whole protective mechanism is called the quantum Zeno effect. You know that old saying, a watched pot never boils? Well, in the bizarre world of quantum physics, that can actually be literally true. The simple act of frequently measuring or observing a quantum system can kind of freeze it in place, stopping it from changing. So how in the world does the universe watch itself? It's actually pretty cool how it works. So first, imagine a tiny patch of space starts that quantum tunneling process. It's getting ready to make the jump to the true vacuum. But, and this is the key, before it can finish, it gets bumped by a random particle floating by, maybe a photon from the early universe. That little interaction acts like a measurement. It basically sees the universe in its current state, and that observation forces the whole tunneling process to stop and reset back to zero. And this isn't some rare event. The universe is absolutely swimming in a constant bath of particles and radiation. So these tiny little measurements are happening constantly, everywhere. In a way, the universe is hitting the snooze button on its own apocalypse over and over and over again, which dramatically slows down the whole decay process and keeps us stable. But, and there's always a but in physics, isn't there? This whole watched pot effect isn't a perfect shield. It turns out there's more than one way this could all go down, and our little quantum guardian only protects us from one of them. So we've basically got two main scenarios. On the left is that bubble scenario we've been talking about. That's the one that's slowed down by the quantum Zeno effect, because as that bubble starts to form, particles from the outside can bump into it and reset the process. But then you've got the one on the right, Hawking-Moss decay. And this one is the whole shebang, our entire observable universe tunneling all at once. There's no bubble, there is no outside for particles to watch from, which means the quantum Zeno effect has nothing to grab onto. It's a loophole in our cosmic protection plan. Okay. Let's pull back from the deep physics for just a second. Because whether the end comes from a bubble we can't see or a universal shift we can't stop, the real takeaway is exactly the same. Our time here is finite. Lawrence Krauss tells this amazing story about a wonderfully dark piece of wit from his friend, the late Christopher Hitchens. It's just the perfect cosmic punchline. You know that ancient, profound question, why is there something rather than nothing? Well, the chillingly simple answer from physics might just be, just wait. Now, the point of all this isn't to be depressing. It's actually to be clarifying. The universe had a beginning, and we know it's going to have an end. Our existence is just this brief, extraordinary flash of complexity happening in that huge timeline. It totally reframes your perspective, doesn't it? All of human history, every triumph, every struggle, it's all happening inside this tiny, fragile, temporary pocket of stability. And this brings us right back to where we started with Lawrence Krauss, and what I think is the real takeaway from all this. If the universe doesn't have some built-in purpose for us, that doesn't leave a void. It creates an open space, a space for us to fill. Like he says, we make our own meaning. Our friendships, our art, our discoveries, these things matter, not because the cosmos tells us they do, but because we say they do. Our significance isn't something that's given to us, it's something we build for ourselves, right here in our brief moment. So the fact that we might only get this one shot, well, that makes every single moment infinitely more precious, doesn't it? It turns our brief moment in the sun into something we should celebrate, not mourn. So I'll just leave you with this to think about. In a cosmos that is so vast, so indifferent, and ultimately finite, what gives your life meaning? What are the reasons you create?